All right. So this lesson is a bit of sugar on the top because it is not 100% related to the core of the stateful set. And I'm not going into all the details here. It's enough to say that you have to organize somehow the access of an application to a database. We've shown in the example of the container, of the Postgres container using psql, how this could be done in a way that we used an environment variable to specify the password, and we used the DNS name created by the headless service to connect to. In technologies such as Cloud Foundry, where you have applications and service bindings and services, this is much more convenient, and you don't have to take care of creating a user, which is a tedious task if you have multiple microservices accessing the same database, which you may be doing if the microservices have small concerns, and then running a separate database cluster for each of the service of the microservices isn't worth the overhead. So you'll have to take care of that yourself in Kubernetes, which is so to say a good point to further improvements. But this is a Kubernetes native tutorial, so we'll look into what are the things you can do. First of all, the default user is called Postgres, which is a very powerful user, and maybe too powerful to grant access to applications, where the least privilege principle should be used, so that the application user is restricted to the permissions that is barely sufficient to execute all the commands that the application wants to issue against Postgres. So here's a simple web application. It's similar to the Go application we used earlier. It's again poorly written Go code. So the source code is linked. It's on GitHub. It's basically nothing more like a Hello World application reading from the company table and connecting to the database. So that's on GitHub. It's Julian Fisher Julian, and let's have a look if we can find it. Simple Go PG. So look at the source code and you'll see the embarrassing simple application. So it basically takes the username as from an environment variable, username, a password, and a host name. It then builds together a username in possibly not the most secure way, and then select the name from the relation called company. So shows a simple response with the name of the company. All right. So the relevant part of the source code is this one, because this one is basically reading environment variables. This is what you'll have to do if you mount your secrets as environment variables. If you mount them as files, well, then obviously you have to access a file. Some services do that, and then it makes sense to mount a file instead of an environment variable. So we need to come up with a username, password, and host name. The host name is already clear. We've seen that in the last example. But now we have to create a database user. we now execute a bash directly on the Postgres server itself. So we're basically creating a bash inside of a running container. Well, at least that's the idea. Or still, TTI was still bound to another process. That's why it didn't work. So now we are inside the Postgres container. The Postgres pod has only one container, so it automatically connects to that container. So if you're familiar with Postgres, then you have this create user command, and it's the Postgres container image. So it already has all the commands ready. So this is the way how we create a further user. We use the username Postgres here because we need to authenticate ourselves as the user Postgres. And we also need to authenticate the user Postgres. Stupid. So the password for the new role is going to be this one. And so we should now have a Postgres user. The Postgres user per default does not have many permissions, so we first have to grant permissions. Yeah, so this must be Postgres, not PostgreSQL. And then we grant the privileges. We'll test the user access. By running a psql container. I just had the session already open. So we are now authenticating here with the user So data is still there. We actually wanted to use the other user. Yeah, this is the username. It's Jaimoldi. And the minus D actually refers to the name of the database. So as you can see, that works. And we've created a username. So now we can create a user secret, which takes the host name, the username, and the password we've created and puts it into a secret. So we're using 3 literals. Do you know that a secret is a set of key value pairs? So we have 3 key value pairs: Postgres host, Postgres username, Postgres password. Give it a go. Describe and see whether it has worked, because eventual consistency and so. Yes, looks good. So now it's time to create the PG app Here I describe in the tutorial in greater detail how I create this YAML file, but let's look. File name is called Postgres application. And you can see that we have one container. It relies on the simple Go PG source code, the one that I showed you here on GitHub. And this application expects 3 environment variables. And in this case, we have to mount the environment variables from the secret. We have done this before, so it's a bit of no-brainer, just a cut and paste exercise. Postgres username is name of the environment variable, and it takes its value from a secret key. You can use a secret key or a config map key here as a reference. The name of the secret key is the name of the secret refers to the key values set that has a key Postgres username and contains the username. Analog to this, we create the password and the host. We open a port 8080, and well, we do have a restart policy. So nothing complicated, nothing that you haven't seen before. So we kubectl apply -f. (40) Postgres. Yes. Okay. And as you can see, the application running container is running. We can also create a service for the new application, which would be 50 or pg.yaml. Create a simple service. Kubectl apply this service. So this is the name of the service. We're now creating another pod running inside of Kubernetes with a shell. We check whether we can resolve the name of the application. So yes, so this means that the application has been successfully bound to its service. We check whether we can resolve the database, which is the case. And we curl the application on port 8080. Oh, that doesn't work either. Is there a port mapping? No. Oh, we have to check whether why this doesn't work. So kubectl get pods. The application is running. Looks good. Seems to be working. All right, so I'm curling directly from within the container, and you can see that the company is Any9, which means that it successfully retrieved the value from the database. So, to wrap it up, because we are running out of time, we have created the StatefulSet. We have seen that the StatefulSet has a stable network identity by using a headless service, that each pod has a stable identity, has a name, and that using the headless service is a huge advantage because the headless service allows referring to the pod without using its IP address. If you tamper with the pod and the pod will be recreated, the IP address will change, the headless service will be updated, and the name service will know that, so that all applications referring to the StatefulSet via its headless service DNS name will work perfectly. So this way you have a stable network identity. We've also seen that you can delete even a pod of a StatefulSet, and that the persistent volume claim and thus the corresponding persistent volume will be reassigned to that particular pod, and that each pod with its identity will be recreated once it fails. This makes the StatefulSet very handy when automating data services because of these abilities. So keep in mind, if you want to operate a database, choose a StatefulSet. So thank you very much. This is has been the last session so far. We are very likely going to add further lectures and further lessons for you in the webinar. We are going to have a final exam where you can challenge your Kubernetes skills with a little challenge on pushing the boundaries into reading the official documentation. But you should have gathered a feeling for the technology good enough to proceed with your own learning. If you're watching this training on YouTube, please share our videos, please give it a like, please subscribe to our channel, as this will only be continued if we see that people like it and that people use it.